Hi, this is Professor Smith, and I'm going to talk now about the IR sensor and line following. So how does the IR sensor work? Well, the IR sensor actually sends out light from the little board that you've put on your robot. It then receives a reflection from that light, and based on the value that it receives, you can determine if it's light or dark. In our case, we're going to send this to the analog pins, and the analog pins are numbered 14 through 19, and they're here as I circled them. And the analog pins will then receive this value and look at the voltage readings between 0 and 5 volts. And depending on what that value is, it's going to return a number between 0 and 1023. So to read that value, you're going to use an analog read and then the pin number. And as I said, it's going to return a value between 0 and 1023. We're going to use our IR sensors to determine light or dark. So on your line following board, we'll have a white background with a black line on it. The sensor readings will vary based on distance from the object. So in other words, if you're very close to the object, you'll get one reading. If your legs on your IR sensors from your robot down to the ground are longer, you'll get one reading, and people with shorter dowels will get a different reading. This means you need to configure your readings for light and dark based on how your robot's configured. This will also vary based on lighting in the room, such as sunlight will make a difference, or if you have the lights on or off in the room, that may also make a difference. We're going to use 3 sensors. We've got our left and right sensor. These 2 sensors are set up so that they'll be on the outside of the line if the robot is centered on the line. And we also have a center sensor. This provides for better control. So as your robot is drifting in one direction or the other, you can also use the center sensor to tell you that you've gone off the line. In addition, because you have that center sensor, you can also determine if you see all white. In other words, all 3 sensors are seeing white now because you've drifted too far off the line. You can use that information to determine which way you drifted. If you only had 2 sensors and you saw, let's say on the left side, left saw white, then left saw dark, which means you're now on the line and you're drifting, and then left sees light again, does that mean you corrected and you're back to straddling the line? Or did left drift so far over to the right that it's now off the line on the right? But because of the center sensor, you can actually determine which way you drifted and which way you should correct. If we were to go further with our IR sensors and our line following, having 5 or more sensors is actually very advantageous. With 5 sensors, you can determine if there's intersections or lines coming up on the side and figure out if you want to turn left or right on those lines. So if we were going to do a full maze following, we would want to have at least 5 sensors. So here are the readings from my IR sensors. I have 3 sensors on pins 14, 15, and 19. Those are all analog pins. And as you can see, I'm getting different values right now. Pin 14, which is my center pin, is receiving an 845 value, which means it's on black. And then my pin 15 and 19 are receiving lower values, and one is on white and the other is close to black, but I would still consider that light. So I've got 2 lights and a dark, and that's what you see throughout this sample. So the threshold value, you're going to need to determine for your configuration what is going to be light and dark. You're going to need to do this through testing out your sensors, so you write a very small program. All that program does is read the sensors and print out the values. You then can put your robot on black and white surfaces and see what's returned. So let's talk about how you can put this in your code. First, I suggest you separate your sensor reading software from your control state machine. The sensor reading functionality, and I would say put in a function, is going to read the sensor, look at the value returned, and see if it's light or dark. So you've set your threshold based on some testing you did previously. Then that function is going to return whether it's light or dark. So maybe it returns a true if it's light and a false if it's dark. And also, as part of this functionality, you can set the LED on or off. And so the LEDs turning on or off are a great way for debugging. As you're driving the line, you can look at the LEDs, and if it's all of a sudden driving off the line and the LEDs don't reflect what you think they should, you can go back in your code and maybe your sensors aren't reading right, or maybe you're just not controlling it correctly. The other part of your code is going to be your control state machine. This part of the code controls the motors. And so you're going to use your function that reads the sensors. It's going to return which sensors are seeing light and which are seeing dark. And then you're going to use that to speed up or slow down or stop your motors such that you track the line. Some thoughts after having played with our robots. First, our motors don't respond quickly to changes in pulse width modulation. So as you change the speeds of your motors, they don't respond very quickly. So if you're drifting left and you go ahead and speed up the right motor to try to push you back right, it may take a while and you actually may drift off the line to the right before your motors actually kick in. Our motors also don't stop immediately. We don't have the capability to force them to stop instantly. And so therefore, even if you stop the motors, let's say you approach and hit the line and then you say stop, the drift may continue and you may continue to drift over the line in whichever direction you are going. Going slower makes it easier. So while the ideal would be to go as fast as you can, I would suggest you start out with a slower speed, maybe a 150 on your motors, just to see if you can get it to work. And then over time, as you improve your algorithm, you can then speed it up. A very simple approach that I found that works is, let's assume in this example that you're drifting to the right. So in other words, the left IR sensor is going to hit the line and see dark. So if the IR sensor on the left sees dark, you stop both motors. Then you take a slight turn to the left. And then once the center IR sensor sees dark again and the left IR sensor sees light, then you would start both motors up to move straight. What I found is if you just continue going forward without actually making this turn, you'll tend to drift off to the right and need to make a much larger correction, because at the point when your left sensor sees the line, you are actually facing to the right. In other words, if you were to drive straight, you would drive off right. And so therefore, even as your motors continue to move and you speed up the right motor to correct for this, you've been driving to the right for a little while and take a while to get back to the line. As I said earlier, slower is better. I found this to work at a speed of 150. I'm sure you could make it work at faster speeds with some testing. In addition, this does give a very jerky line following solution because you're stopping every time you hit the line. So there are better solutions for this. You can adjust while you're moving. You can adjust and you can be moving faster, but you're going to need to have much more thorough analysis of how your robot works and also how quickly and slowly your motors adjust, and also a much more in-depth state machine.